So, today we will discuss on the part of like balancing of multi-cylinder engine. That is also inline engines, right? So, multi-cylinder, we will basically discuss from first four-cylinder engine. Suppose this is cylinder one, this is cylinder two, this is cylinder three, and this is cylinder four, right? And we have something like this is a crank one, right? This is crank two, this is crank four, and this is crank four. Sorry. Here in the cylinder there will be piston. Here there will also be a piston. Here there will be piston. And here there will be piston. So this piston is connected to this. This is connected to this. This is connected to this. And this is connected to this. This is cylinder one. This is two. This is three. And this is four. Right. So consider the center part. This is center part. Right. So the center part, and this is something like this. This is center part. थोड़ा इसमें भी change. This is center part, right? Here the distance, this is L1, this distance is L4, this is L2, and this is L3. And this will be our reference plane. Okay. So we can see sorry, the crank angle here from this to this, there is a 180-degree difference over here. Right. So one cylinder in our Cartesian coordinate system, we can see the cylinder one will be here. Cylinder 2 will be here, cylinder 3 will be here because these both are in crank position, and cylinder 4 will be here. Okay, so what will be the angle for the crank? So we can say, like, for the crank 1, the angle is 0 degree. For crank 2, this angle is 180 degree plus 0 degree. Crank 3, this will be again same 180 plus 0 degree. And crank 4, it will be 0 degree again, the initial position, whatever we have, right? So here, what in previous section we have seen, like we need have force primary and secondary unbalanced force, right? But here, this is that was only one engine, right? Here we have multi-cylinder engines, four cylinders, so and we have distance also. So this distance will create a couple. So here we need to have couple, primary couple and secondary couple, right? So primary couple will be what? What is a primary couple? So again, it's a mr omega square cos theta and mr omega square sin theta. So for primary balancing of multi-cylinder engine, primary balancing, all the forces should be zero and all the couples should be zero. And for secondary balancing, all these secondary unbalanced force should be zero and secondary unbalanced couple should be also zero, right? So what is primary unbalanced force should be zero means? So let us understood. So what will be the primary unbalanced force should be zero, right? Here we need to first understand the analogy between these two. So parameters of primary and secondary. सबसे पहले the crank radius will be the same crank radius, right? But we'll explain this later. Angle theta, this secondary, the angle will be 2 theta, right? Speed here omega will be at 2 omega in secondary, right? So to balance this 2 omega and 2 theta, this will be 4 by 8. So this is the parameter we need to understand. right? And for couple, we should have multiple by length. So that is what we have discussed previously will be the same. Okay. So let us understood one example based on this. Suppose there is a mass, right? So mass will be suppose all having the same mass. Then radius, all having same crank radius. Then what we are calculating MR. So this all will be MR. This will be MR. Angle. So we have defined this is 0, this is 180 plus 0, this is 180 plus 0, and this is again 0. Okay. So this is theta. So what will be the 2 theta? So 2 theta will be 0. This will be 360 plus 0. This will be 360 plus 0. And this will be again 0. Okay. Then we have a distance from reference plane, that is L we are denoting. So what we have seen, the distance from reference plane left side will be negative and right side will be positive. So L1 and L2 will be negative, L3, L4 will be positive. So this will be minus L1 minus L2 plus L3 plus L4. And what will be the MRL? So this will be minus MRL2 plus MRL3 plus MRL4. Okay. Now, first we will draw primary positions. So primary positions in the crank position we have shown, the one will be here, second 180, so 2 will be here, 3 will be here, and 4 will be here. So let us have primary force polygon. So how to draw force polygon? Force polygon. So force polygon we need MR only and angle. So we'll start from here. Suppose this is 0. Then MR by scale. Suppose MR we are considering as a MR as a 2 centimeter. Suppose random you can see. So at 0 degree, I need to draw a line. This is MR. This is first position. Then angle is 180 plus 0. Angle is 180 plus 0. So I have traveled here. Then I will travel from here to here. This is again MR, right? Then again there is a 180 plus. So I will travel here. So this is again this is A, this is B, this C, right? This is again MR and 0. So you will be away. So your polygon is closed polygon. So the total balancing force on primary force polygon will be 0. Now we will have couple polygon. So for couple polygon, what we need to consider instead of MR, we will consider MRL. Okay. So what will be the couple polygon? Primary couple polygon. So couple polygon, we will start from 0, right? 0 minus MRL1. So 0 degree, if we have a 0 degree, need to draw in this direction, but we have a minus, so we need to draw in this direction, right? So what will be exact? So as L1 is a larger distance, so I'm taking it's a larger. So it's A, this is 0. This is MRL1. Then 180 plus 0. 180 plus 0. And this is MRL2. 180 plus 0, 180 degree, I need to draw in this direction. But this is negative, so I will draw in this direction. And L2 is a less, so I'm considering this one. So B position. Again, 180 positive MRL3. So 180 positive. So 180 degree. Here you will go. And this will be your C. And 0 degree MRL4. So L4 is the larger distance. Again, same as L1. So you will reach over here only. So again, you are reaching at your initial position. So couple polygon is 0. So we can see this is primary and secondary is a balance in a balanced condition, right? So there is no unbalanced force in primary and there is no unbalanced force in secondary. So now we will discuss about the no unbalanced force in primary and no unbalanced couple in primary. Now we will consider secondary. So for secondary, what we need to understand, we need to, uh, we need to take secondary angles. It's a 2 theta. So again, you can see this all are zero, actually 360, but 360 again zero. So this will be 0 degree and same MR. So if you start to draw force polygon, you will start from A, then B, again zero only. So this will be C, this will be D, and last position, right? This will be E, suppose. Then this will total unbalanced force will be there. Unbalanced force will be there. And this unbalanced force will be 4 into M into R. What will be the unbalanced force? 4 into M into R. And this is omega square upon N. 4A MR omega square upon. Okay. Now we will draw for secondary couple polygon. So secondary couple polygon is what? It's a double of this one, and couple will be having a distance. So if we start from here, we have a zero first of all. The zero should be in this direction, but we have a negative, so we will move in opposite direction. So we move to L1. So this is A point. Then 360, so zero again, but we need to move in another direction. So zero is in this direction, we need to move in this direction, right? So this will be your B point, then zero, your C point, then L1, again initial position, right? So here you are returning to same original position. So you can see there is no balancing required in the couple. So in secondary couple, zero unbalanced couple is there. Only there is a one unbalanced force in secondary force polygon that we can consider. All right. So that is shown over here. Okay. So that's it.